Hi, everybody. Sarah here. I want to welcome you all to the Everything Robots Spike Prime session. We're hoping to be able to answer a bunch of your questions tonight and give you some information about some good resources. And I'm going to pass it over to Jay Kinzie now. Thanks for doing this, Jay.
Awesome. Well, it's a pleasure to be here, as always. I've been doing this for a really long time. I've been doing this since the year 2000. So I've seen a couple of seasons, and I've had a lot of different roles along the way. My sort of core area that I like to focus on is robot related stuff, which is kind of what brings us all here today. And so I want to start today off by kind of opening the floor up to questions and seeing like what questions do you have about robots or about the whole robot category in general, and also maybe specific technical questions that you might have regarding Lego Mindstorms or anything on that sort.
Hi, this is Vinay. I have not started yet looking at the Spike. Till now, my team we started using EV3, and this is the first year we are moving to Spike. And I know I did not open the kit as well. I just got it. So from the EV3 perspective, we'll have the blocks and all where we can write the programming to connect by connecting them. But we want to right now use Python as language. That's one of our goals, and also use Spike. So any inputs you can give me, that will be helpful.
Yes, and actually, before we get going, I made a list here of good resources. So I wanted to put that in the chat. That's for everyone. If more people show up, please share this as much as possible. It's just a collection of really good links related to like learning, programming, everything. People who've done cool things in the past, people have cool YouTube channels, stuff like that. We can specifically go over like some of these things in the resource tab in this, in the resources, talk about them specifically, but just for now, make sure you have this link, open it, look at it, et cetera, et cetera. Okay, so regarding like Spike Prime specifically, to talk about Spike Prime programming, it does have the same, not the same, but it has a similar graphical drag and drop system that all the previous Mindstorms products have had. Spike Prime is unique in that Python is an officially supported language as a programming method. In the old days, that was not the case. You can only use a very specific firmware on your on the Mindstorms. You can only use the factory firmware and the factory programming. But sometime in the last couple of years, I forgot which year specifically, they opened it up to anything, right? Which is something that had been talked about for a long time, and they thought that now was the right time to do that. So, talking about probably a good place to start is, where's that transition point between the GUI and Python, right? Python is a really interesting language in that it's, as far as text-based languages go, it's really easy to learn and it's fast. Like it's fast to pick up, it's fast to use, and you can write programs that are very, very effective very, very quickly. Is it going to be more complicated than the GUI? Maybe a little bit around the edges, but that programming language in the development environment is streamlined as much as possible to make that as reasonable of an experience as possible for people to get into text-based programming. Some people also really like Python because they find it more readable. Some people, the big blocks, take up a lot of area on the screen. They like sort of the more concise nature of the Python programming. The Python stuff's also probably executes a little bit faster as well. So if you're looking for, more performance, like, in terms of like loop times and stuff, that could be a good option. This last year, there are actually a lot of bugs in the Python side of things. And I think a lot of those have been resolved over this last season. So if anybody wanted to get into Python, now is probably a good time because the platform's probably as stable as it can reasonably be at this point. Does that start to answer your question? Am I going in the right direction?
Yeah, you are. Thank you.
Okay. So the one of the things that's really convenient about Python is that it's really, really common, right? You're going to come up against situations where you don't understand what the compiler is telling you. You know, you're not sure why it's not working. And Python's one of those languages where you can sort of put into Google what your problem is, and you'll get a reply back, and that'll help you a lot, right? There's lots of really great Python specific stuff online. You can Google, how to learn Python on YouTube, and it'll take you as far as you want to go, essentially. So part of like when you would want to jump into that's going to depend on your kids. I would suggest starting with the GUI if they haven't ever seen programming before, and then move to Python. But if you've done the GUI for a year or two and you want to try something that's a little bit different, that's maybe a little bit more flexible, that's a great place to dive in. Another thing to note is if you start the process of trying to learn Python, you can always go back, right? You're not stuck with one language or another the entire season. So you can start with the block programming, find that you want to do more, then go to Python, or you can start with Python, find that maybe you really want to go do the block programming instead and go do that. So don't feel like you're stuck with one option or the other. So I would definitely give it a try. Because we're also preseason right now, I would definitely say like now is a great time to put your thinking cap on, try writing a couple of basic programs, make sure everything's working the way you expect it to work. And then when the season starts, your team will have some practice and be ready to start, programming submissions and things like that.
Yeah. Thanks, Jay.
Cool.
Hey, Jay, one more question. So besides the performance, would you rate like using a Python program versus using the GUI on the same pedestal, or does one get an edge over the other in terms of what we can achieve?
In terms of what you can achieve, you can technically achieve the same level of functionality with both. But if you're trying to do things that are more complex, it's going to be easier to do them in Python. So if you're a competitor and you're starting from ground zero and you keep using the block programming will help you in the beginning, right? It'll help you learn those basics very, very quickly. But at some point, the child as a competitor will outgrow it, and the blocks will start holding them back rather than helping them. And then that's that point where you want to start getting into that Python, where there's now more things to learn, more flexibility to be had, more complicated algorithms to write. And in that context, it's going to do better.
Okay, got it. Thanks.
While I hear that question, one more thing is, can we do mixed, like while we are using GUI, and then if we want to do something more on it, is there a way we can use Python as well as the blocks?
That's an excellent question. I don't think you can do that in the same program.
Yes, you can.
Okay, well, there you go. You apparently can. So
not in the same program, but you can have one program, say like program 1 can be Python, program 2 could be block.
Right. So yeah, on a per program basis, but not intermixed within a single program.
Awesome. Thank you.
Yeah, there's no like switching of firmware required or re-downloading firmware or anything like that. It should just all work. I know there's a lot more out there. I'm waiting for it. Could be anything. Doesn't have to be specifically Mindstorms. Could be anything about the robot side of judging as well.
Yeah, I guess I have a question here, Jay. Now with the Spike Prime, we have the ability to have 6 ports that could be either motors or sensors. Is there any talk about allowing additional motors besides 4?
No, that's something that comes up a lot, and I've talked to the Lego folks a lot. And for the purposes of first competition, that's probably not going to happen. There's several technical factors which are a limitation to that. One of which is the ability for the brick to deliver power. There's only so much power that the brick can supply. So 4 is probably where they're going to keep it just for that alone. And 4 is also kind of a lot. Like, I come from the days when there were 3, and we would have given anything to have a 4th motor, much less a 4th motor with a built-in encoder. And I just couldn't see them going beyond that in any kind of gameplay style at this level. There could be opens, or maybe some other unofficial competition or something that might have slightly different rules that would allow that. But in terms of like stock competition, they're probably going to leave it at 4. Also for cost reasons as well, they'll probably also leave it at 4. The curriculums are probably going to be built around 4. It's just going to be easier for them to kind of aim towards that than it will be to sort of go beyond that. But are you finding that you're running the limitations with 4 motors, like you wish you had more?
Well, I always want more, of course. It would be an interesting way that could change the game is if you could attach a motor or put a motor on the attachment and then just plug that motor in and swap it out. So then your attachment itself would contain a motor. The kids have built some interesting, playing in the off season, built some interesting attachments where the motors were actually part of that attachment, and then they just plugged it in. And that way you could have, right now you could have endless sensors pretty much, but you can't do that with motors. And that's, if the rules were to change that way, they could completely redesign how their attachment thoughts were.
Yeah, that's true. That's a good point. From a gameplay perspective, or I would say from more of a robot usage standpoint, one of the things that's always going to be challenging whenever you put motors on attachments is actually plugging the motor in to the brick. Now the Spike Prime is interesting in its design specifically due to its wires, because the wires now are friction fit. They just pop in and out, right? They don't actively clip in. So it's a lot easier now to, like, you could just yank a motor out and it would come right out of the port, right? As opposed to if you did that with a NXT or EV3, you would actually damage the cable, because it's kind of like a headphone jack cable, but not quite. So that's more possible now from that standpoint. But from an operator standpoint, they're going to spend extra time having to plug it in manually. That's probably not worth it in terms of time. You could probably design a system that does what it needs to do without having to have that much operator intervention to keep the attachment changes fast. So, for the topic of like motors in general, that's always one of the challenges, right? Like, how do you get motion to a certain place, whatever that is, right? An easy starting point for that is looking at pneumatics, right? Having that pneumatic tank with the pneumatic wires, or not wires, but the pipe or the tubing, pneumatic tubing. You can use stuff like that to bring energy, power, function, and motion wherever you really want it, right? It might not be fully continuous. It might not be as on demand as a motor, but in a lot of instances, you can make whatever you want to work with pneumatics. You can also use other types of stored energy. Typically, actual Lego wind-up motors are not allowed, although I'd have to check the rules, double check it to see if that's the case. But you can also build your own wind-up motors, which is totally legal and always has been and will be. So you could, for example, have some pneumatic tubing that you roll up because it's really flexy, for example. Have some pneumatic tubing as your elastic element, or the actual Lego rubber bands as an elastic element. You could use something like that as stored energy. You could also use gravitational energy, potential energy. You could have weights that fall that, turn gears and winches and things like that. And that's another way to get energy. So there's definitely ways to move things where it doesn't require a motor. But you just have to think a little bit differently in order to do that.
Hey Jay, this is Bhaskar. I have a couple of questions. Might be still novice to this Python programming and getting familiarized with Spike. Is there a place where you can? I know that on the knowledge base, if you go, there are like you can go through the scroll to the APIs. But is there a single place where you can go and look at all the APIs together, rather than looking in a textual manner?
You know what? I thought there was, and I thought it was on the Lego website, and that's a good point. I'll see if I can find that after the call, and if I can find that, I will add that to the sources tab, or to the resources thing that was posted earlier. I just reposted it in the chat, but if I can find that, because I think it's on the Lego website. If I can find that, I will put it there.
Sure, I was trying to find it. I couldn't, but so far I might be.
Yeah, there's other people also that I can reach out to and ask who, if I can't find it, they would know if it exists.
Sure, definitely it's on the knowledge base, but you have to go through like a lot of text for each one. It's not like like where we other Java programs, you find the APIs at a single location and you open it, you find out the more details about it. It's not like that. So just trying to see if there is any better way to find out easily, to know at a high level what are all the APIs that are available.
I'll double check on that specifically.
And one more question might be a novice question again. Is there a way like when you install the Spike and then you run the Python program where you can go like step-by-step execution rather than a full program execution?
Single block. Not that I'm aware of, but that's something you could probably build in your program. Just have it keep doing something until it hits the touch sensor. But I don't think there's a single block execution mode.
Okay. Because other compilers where you will have like you can
debug mode basically.
Debug mode. I was trying to check if there is any debug mode. Like when I run execute a program, I don't want to go to that dead end of all my lines of code. But one step at a time might be to explain to the kids as well. When you do this one, this is how it is working, right? Rather than running the entire program.
I'll double check on that. That's another really good question.
Sure, thanks. So these are the couple of questions I have. Thanks. Yep. And is there a way, like I know that it might be in your doc, if I have to go and check, there is a forum to communicate or ask questions. What is the best?
So for interactive communication, I'd say FLL Share and Learn on Facebook's a great place. In terms of like interactive communication, that's probably one of the best places to go. In terms of just learning, pretty much anything by the Session Brothers, which is also here in the FL resources. EV3 lessons, Spike Prime or primelessons.com or org. It's primelessons.org. FL tutorials, there's a lot of learning in there. So for a single player experience, that's a good place to go. But FL Share and Learn is probably a really good interactive place to go.
Okay. Thank you. Yep. If there is anything you stumble upon, try to check how others are doing, right? So thank you.
Hey, so I have a question on the design of attachments, and I'll do my best to articulate my question. So it's like two schools of thoughts, I would say. In one case, we feel like if we use let's say, minimize the number of attachments to complete the missions, then we're going to keep it simple, right? So let's say we are able to achieve all the tasks with one attachment, well and good. We don't have to keep swapping them, save time, all that fun stuff. While it seems simple, but then that's probably going to take more creativity and come up with innovative solution for the design of the attachment itself. Whereas the other school of thought would be, okay, if I do more attachments, I can showcase the creativity better. So in terms of judging, which one would be more favorable?
So that's an interesting question, and that's a really interesting way to put it. From a rubric perspective, it actually doesn't, strictly speaking, matter. What does matter from a judging perspective is having the kids show the work on why they made certain design decisions. So whether they have 3 attachments or 5 attachments, being able to, show in an analytical way that they chose something for a specific reason, which they have proven against, other possible solutions. From a judging standpoint, that's what's going to matter the most. From a strict robot functionality perspective, which is, by the way, one category out of the 10. If I had 2 robots in front of me and all other things being equal, and one of them had fewer attachments and did the same thing, I would consider that one a better design. But that's, again, only one category, right? And also, if you look at the categories on the rubric, beginning, developing, accomplished, and exemplary, some of those categories can be pretty wide, right? So, for example, if the fact that you're sort of even thinking about this, it probably means your team might already sort of be in that accomplished area. And if you had 2 robots that are sort of both doing a really, really good job, and they might be doing it in different ways, they might both fit very easily into the accomplished category. So from a judging perspective, it really might not actually matter at all. But what will matter is having that rigor to show why the decisions were made. That's what's going to put them into that spot where they want to go, is having that background on why they did what they did. But if you can do it with fewer attachments, I would encourage it. I always like to think that the ideal robot is one that you put on the table and you hit go and you walk away. And haven't really seen that yet.
Jay, can I jump in
Yeah,
real
so
quick
that's
here?
Sure. Yeah.
So I'm a judge for both robot design and programming, mainly programming.
Mhm.
And if you look at the rubrics, especially with the changes in the last 2 years,
Mhm.
it's a huge amount about show me the process, tell me about the process. And what you were saying is, if the kids can say, this is where we started, and then we weighed these 2 against each other, and then this is the decision we made, that's huge, instead of just, do I have a really cool attachment? I mean, we all love cool attachments, but tell me that process. How did you get from here to here? What decisions did you make? That is what's going to, according to the rubrics, should score really well. Not just a cool robot design, but tell me the process the kids went through.
Precisely. Yeah, the majority. I'm trying to find one of the rubrics real quick, just so I have one in front of me. I should have brought one up earlier, but I forgot. But yeah, the rubric itself is, if you look at every category, it's much more about why you made the decisions you made. And part of why first sort of made that tweak in the actual judging process was because they felt that the goal of the robot design is not to predict the robot score, right? They want to separate the robot design from the robot performance, right? So that emphasis on making those design decisions and why things were done is intentionally trying to be a very separate thing than just straight performance on the table, because they're trying to decouple that. So that's where that split sort of comes from, and that's a newer concept. Yeah, you want the rubrics? Yeah, sure. They're publicly available. League rubrics.
Hey Jay, there was also a question in the chat. There was some formatting issues with it, but it was asking about a trifold Lego table design. I'll pull out the links just a sec.
Okay, replay rubrics. Okay, here we go. I'm sorry, that's the neighbor's dog. It's kind of barky. Yeah, so there you go. Rubrics are now in the doc, and for good measure, there you go. They're publicly available. They're intended to be publicly available. They've always been publicly available. So let's see. Take a look at this trifold table. Yeah, there's a lot of interesting designs out there for tables. So I'm actually the co-inventor of the first commercially available table, which is from AndyMark. And in Illinois, I built all the tables we use now. So a lot of you might have actually run on them at the state competition. The last time we had a physical state, I built all those in my garage with my CNC machines, and I had custom extruded walls and stuff like that I had made. As far as this specific table design goes, that's here, that looks like a really cool design. From a legal standpoint, it looks fine.
I would say two things about it if I can pop in for a second, just having helped build some of those tables, Jay. The hinge on the upper part of the walls could potentially get in the way of any like attachments that we're doing, like wall rabbing or anything like that. So that might be a consideration. Probably pretty minor, but also the walls are wood, which would make the table pretty heavy. So just two things that popped out to me.
Yeah, I've actually built that threefold table before, and it is pretty heavy. And yeah, the hinges do get in the way. I ended up giving it away and did buy last year. Not that I'm pimping Jay's table, but I bought it last year and we used it all season, and it was a lot better to throw in the back of an SUV. It was really light. The kids could take it in and out without any problem. And it's got plastic walls that are hollow. It's just really easy. It snaps together tight. Like I said, the kids pulled it in and out without a problem. So the weight issue when you're talking with kids is the big deal.
So I just put the link to the table from AndyMark that I co-created and that also Mike was talking about. Yeah, weight was a absolutely huge consideration. And also being able to break into 3 pieces that are relatively light means that it's a lot easier to have kids carry it. It's not really reasonable to ask a kid to carry like a full 70-pound table, but like a 50-pound table divided by 3. Yeah, you can ask a kid to carry that. That's okay. So, from that perspective, it's a lot easier. Also, yeah, again, throwing it in the back of the car and stuff as well. And when you're not using it, it takes up a lot less space, which is, more convenient. From a rules standpoint, generally speaking, I'm sorry about the dog. At least the outsides of the walls, like the outsides of the play boundary, are generally speaking not guaranteed. However, I've done the most that I could to try to keep all of those outside areas as free from external elements as possible. So if you look at the Illinois table specifically, there's just those latches where the tables come together, and other than that, there's no external aberration on the outside profile of the walls. And that's intentional to make it easier for people to wall run and clamp onto the wall or use the wall for alignment and stuff like that. But that's technically not a guaranteed feature. With this specific three-piece design, there are things on the walls, like on the top of the walls. If that doesn't bother you, then it's not a problem. But I'm not really sure what you're asking specifically about this table. If you're asking if it was legal, or if there is a specific question you had regarding that specific table. Oh, okay, cool. I mean, A+ on effort. You went a lot of design effort to get that to work. Yeah, the one of my major goals with designing like a table for commercial purposes was to try to get away from, traditional wood 2x4s as much as humanly possible. For one, the 2x4s that you can get now are generally very low quality. I spent a good amount of time just trying to find a source of wood that was decent, and I couldn't really find one. And so I ended up moving away from wood. Plus, wood also has a lot of issues with warping and stuff like that. It also requires painting, which is can cause problems. And also over time, as the wood just gets used, right, it's going to chip. It can create splinters. You're going to have to repaint it again in the future. Sometimes, small parts get stuck in the wood if there's like a divot or knot in the wood. So that's those are all reasons why I wanted to get away from wood and use plastic extrusions for the walls. Also, just generally speaking, reducing the weight of the table makes it stronger. And I realize that sounds counterintuitive to a certain degree, but one of the things that I noticed in just traditional wood tables, which I have built several of those, which I use as benchmarks, the tables end up being so heavy that they start causing themselves to warp and get damaged over time. So, like for example, if you have like a full traditional wood table and you like have it like hanging sort of like on an angle, or it's hanging off of something like cantilevering, what you'll see is over time the base plate will actually start separating from the walls, right? And that's because there's so much pressure around where those screws are being held in that it's exceeding the pressure that the wood can realistically handle, right? So eventually it starts pulling away, right? And part of that is because of the weight of the table itself applying too much pressure to those very small areas, which causes the pull out and tear out. Is that going to happen to every table right away? No, but over a long time of use, yeah, it'll definitely happen. So I wanted to make something that was lighter, that was light enough where it didn't have trouble supporting itself. But that, like, the table building endeavor on my end was sort of coming from a very different angle of like production and how do we build a whole bunch of these, and if you're going to build like a bunch of these, how are you going to do it, versus like, hey, if you're just going to kind of build one on a one-off, what's that going to look like, versus like, hey, you got to build 60 of them. It's going to change the equation a little bit. You got some more questions? Illinois. So Illinois has the tables that I built for them, which are not the Andy Mark tables, but are extremely similar to the Andy Mark tables. The Illinois tables have essentially the same material as the base plate and the same material as the walls and the same latches. They're most likely fully mechanically compatible. Like you could latch them together, right? Because they're using, the same, all the same parts. The extrusions that Andy Mark uses for that table are from the mold that I had made. So it's literally identical walls.
The difference is one piece versus three pieces.
Yeah,
right?
That's the big difference. The Andy Mark table, can be used in an official competition capacity, but I built a whole bunch of tables for Illinois, so they'll probably use that for a long time.
And it does vary from competition to competition for the qualifying tournaments. Some qualifying tournament coordinators opted to use some of the old style of tables that were being used in previous years. So it's possible that they may be using those types of tables as well at your qualifying tournament. Not every qualifying tournament will have the one-piece Andy Mark tables, but the state competition should.
Right. Yeah, the tables that Illinois has and the Andy Mark tables are completely optional things. They're not required for people to buy or anything like that. They're just options for people, to have, right? So, if you need a table and you don't really, feel like building one, or you want something that's very compact, that's off the shelf, that could be a great option for you. but it's by no means a requirement. Okay, so this question in the chat, new team, where do you get started? You know, this is again, I'm going to default here to the resources document. FL tutorials, EV3 lessons, and Prime lessons have lots of material around that sort of thing, and so I highly recommend that. Cool. Let's see. What are some things that you might have questions about? Judging things. We could talk about rubric things. We could go over the resources tab. No, you can save it. I'm not going to get rid of this. I'm just going to leave this in my Google Documents like forever. You know, maybe I'll update it here and there. But yeah, save it. It's all yours. You know, everything here is, you know, free and available online. There's nothing here that's, you know, proprietary or specific. It's just for everybody. It's just aggregated into one place. Please use it. Share it with other people, et cetera, et cetera.
Jay, what are some lessons that you wish teams would know prior to, like maybe rookie teams would know prior to their first competition for robots?
Well, I would emphasize this for everything, but I would read the rubrics. There's a lot of teams who have delivered us a lot of things that were either tuned to the old rubric or just weren't addressing the questions that were in the rubric, right? So I would study the rubric very carefully and try to make sure that whatever you're doing in your presentations is addressing what's in the rubric. That's number one, right? Like if you're going to go to school and you're going to take a test, what's the one thing you do on a test? You have to address the question, whatever that is, right? So start with that. That's number one. You know, now we have this sort of case where, you know, we've done a lot of remote tournaments, but we're also trying to move back towards the realm of physical tournaments. Be on top of whatever tournament schedule is happening, right? Be in contact with, you know, the coordinators, you know, make sure that you're within deadlines, you're checking your email, you know, all that sort of stuff, right? We don't want to see people miss things because they didn't see their email and missed a deadline. No, nobody wants that, right? We want you to succeed and just do really well, right? So make sure you stay on top of like all the logistical stuff. That's number one, in addition to everything else. Let's see, for other things like in a remote tournament, you know, when you're making your videos, you know, they don't have to be really great production quality, but you know, it's nice if you can have, like, for example, audio that's good, stuff like that. You know, try to, like, if you can, like, try to do some volume leveling. Sometimes we get stuff that's like really, really quiet, and sometimes we get stuff that's really, really loud. So, you know, when you process stuff like that, just try to keep things at a reasonable level. And also, speaking of like making videos, do try to stick within the time constraints. You know, sometimes they vary year to year, but do try to stick to those. And for as many people who go over on their video time, there are just as many, if not even more, who are under time. So I think a lot of people who are out there just don't know that there's like a time limit and they could use more of that time, right? And then some people just go over it. So, you know, if somebody gives us a video that's out of time sync, that's too long, we don't really have a great way to deal with that, right? So
I just want to chime in here because it does look like this year we're going to be returning to in-person events, and with the in-person events, we are expecting teams to go back to live presentations. So please don't start planning for this season and planning a recording for your project or your robot design presentations. First has made it clear that they do expect us to go back to the live presentations. But all the points about timing and watching your time and preparing all are completely pertinent.
Yeah, and if anything, it applies more in person, just because it's so, you know, there's a certain cadence to the day, right? Like, there's no way we could let you go over a certain amount of time, right? Because we have to get the next team in. So you really have to stay on top of your timing. And you know, right now we're doing combined judging, and you know, that's like a roughly a half-hour process, plus or minus. And you have to manage your time throughout that whole sequence, right? So that's something that can be challenging. So, you know, when I, as the judge, you know, I have my phone that has a timer on it. I know what time it is. But does your team know what time it is? You know, if you're finding you have timing issues, you know, obviously it's something you could practice, but there's also no rule saying that your team can't have their own timer. I just haven't seen anybody do that. Yeah, I think that's good. That's good on that part. You know, in terms of physical competition, like, well, first of all, how many of you are rookies or are new this year? There's a good number of you. I don't know if there's like a raise hand function, or maybe just mention in chat, you know, if you're new, or like, you know, what's our ratio here of, you know, new folks to veterans. So Chris is new. All right, so Chris is new. Thank you, Chris. You know, because yeah, right. Because we've been remote for what seems to be like a long time. You know, going back to in person is going to possibly feel a little bit different. So I would make sure that, for example, you have checklists of everything you need to bring. You know, make sure that you have power strips, computers, backups of backups of backups, obviously your robot parts, spare parts, any medical accessories that, you know, people need, you know, inhalers, whatever, anything you might need. You know, keep track of, you know, if that tournament that you're going to is going to have, you know, food there or not. If they don't have food, maybe, you know, might be on you to bring your own. So if that's the case, you might want to, you know, be aware of that. You know, obviously showing up when, you know, everything's open, you know, in the beginning of the day is going to be important. You know, so we'll just have to get back in the swing of like actually having a physical competition day where everything rolls. So just make sure you're prepared and ready for that. And it's a long day, I know. Should you consider it? Should you consider recording the presentations in case we're forced back to remote events? You know, we really are trying to go back to in-person events, but there's also nothing stopping you from making a recording. It could be, for example, there could be other reasons why you might want to have a recording, for example, for reference. Like if you're doing it a bunch of times and you find one that's like really good, right? You can use that as a training aid to help your team, you know, practice, for example. So it might make sense to have some kind of a recording, just for that reason alone. But I wouldn't say it's a requirement, and you shouldn't feel like we're going back to remote. If we were to go back to remote, there would definitely be, we would make sure that everybody knows that's what's happening, and that there's enough time to make that kind of transition, right?
And
like
also,
it's
yeah, I think we would probably do like a live judging instead of recordings. If we have to pivot at the last minute, just because that is what everyone would be prepared to do. I think that last year was pretty unique in that we wanted to really kind of be as generous as possible and give the students sort of the best Lego forward, right? Because everything was just so difficult. And I think that as we're getting back to normal, all the talk and discussion I've heard is around trying to really be headed back towards normalcy, and normalcy would be a live judging session. So whether it would be in person live or it would be Zoom live, etc., I think that that would be what teams should anticipate as normative for this year. I hope that helps. But I don't see any problem with recording the presentation for a tool for learning, like Jay mentioned. It could be really good for the kids to see themselves in a recording and to review and try to iterate on their presentation skills in order to improve the quality of their interaction with the judges when they do that.
And another benefit too could be if you're working with another team, for example, if you have like some other team you're collaborating with, that could be a great way for, teams to communicate with each other, to share their ideas, or, critique each other's presentations, for example. So hopefully that answers your question, Tim. I haven't even used my whiteboard yet. I'm waiting for some of those really nice, deep technical questions, or deep robot questions that would require a whiteboard. Come on, I know they're out there. I haven't even scratched the top of the depth of what I know. I want to share as much as possible. Okay, Chris. It's great to have you here.
Jay, what do you know about some of the time delays that happen when using Python on an EV3 versus Python on like the Spike Prime? I've heard, because it's running off an SD card, you could have almost like a 20-second delay or something like that. Are you familiar with any of those?
Yes. So the thing about the EV3 is that the EV3 is an actual real computer. The Spike Prime is not. The Spike Prime is actually just a little microcontroller, right? So EV3 runs like actual Linux inside it on an actual ARM processor, right? Like the processors that were in here were in cell phones at one point, right? Whereas the Spike Prime is a microcontroller, kind of like the NXT. So in terms of like time, there can be a lot more load time with the EV3. However, the EV3 will produce a faster loop. It's faster to iterate, and also its sensors also update faster. And some of their sensors also have more resolution. So in some instances, the EV3 is kind of the better machine from that standpoint. Spike Prime's probably overall a little bit easier to use. One of the reasons why they got rid of having actual like processors in here was because of that. The time to boot and potential load time was too high for most users. So they went back to a simpler design that loaded faster. But when you're actually executing your program, the EV3 will be a faster machine.
Can you address, Jay, some of the hurdles that people have had with memory on Spike Prime and how to get around it?
Yeah, so the Spike Prime does a lot of things really, really well, but one of the things that it kind of falls short in is memory size. I believe it has like 32 megabytes of storage in it, which compared to like the SD card on an EV3 is nothing, right? Like the EV3, you can, pretty much put whatever size you want on it, but the 32 megabytes in the Spike Prime can be limiting. So there are some ways to get around that. There's a tool that you can use that actually the sessions made, I believe, that basically compresses your programs inside the Spike Prime, and that can save a lot of memory. But you also can still sort of exceed that level of memory, even while doing that. One thing you can do to help that is make sure that you don't have anything that doesn't need to be there. Like, so for example, if you have 32 megs and 2 megs of that are sounds that you don't use, right, and you're running into memory issues, you might want to get rid of that other stuff you're not using. Also using functions, using code over again as much as possible will also save you room. Another interesting technique, although this is like a very advanced thing, sorry, just dropped my pen, a very advanced thing that not a lot of people do, but this would save you a lot of space, is you can do something called building your own virtual machine. So like normally right now when you program, you in the software, you say, go forward, turn, move a motor, et cetera, et cetera. What you can actually do is you can write an interpreter that reads in a text file, and that text file has the commands. So that text file could have like go forward, turn, use your light sensor, he could have all sorts of commands in it, right? And your interpreter is just reading those commands out of that file and then executing that command. So in that case, the actual code that you write on the EV3 or on the programmable brick is going to be very, very small, and it doesn't really change in size because all you're feeding it essentially are instructions on what you want it to do, rather than having that sort of coming from the binary side. Does that make sense? If you're familiar with something like G code, it's kind of the same idea. A good example is, for example, like 3D printers. It's something that a lot of people are familiar with that have the same concept. If you ever look at the code that moves a 3D printer, it's just lines of coordinates for the most part, right? Every time you have a motion, it's not really adding to the size of the program other than that one little instruction in the line. That's because when you ask it to move, right, it's executing a sequence inside the machine that tells it to move, right? And it's whenever you tell it to move, it's going to execute that same sequence over and over again, right? So it's not adding to the program length whenever you want to do that. It's essentially just reusing that little chunk out of the interpreter and just reading that text file. So if you wanted to, you could have very long text files that have lots of functions in them. So you could map like certain commands in the text file to certain commands on the EV3, and that could save you a lot of room. I saw one team do that last season, but that's a fairly rare feature. Oh, I guess if there's no specific questions. I guess one of the things we could talk about are, good practices. What are some good practices in programming? What are some things that we look at when we program? What kinds of things do we want people to learn, think people to see? One of the most critical things in programming is the idea of encapsulation. So we want kids to come up with, typically would be called my blocks, but they're basically just functions, build basically modules of code that do something and then employ that, in multiple places in the program, right? That's something that we love to see. A lot of great documentation on how to do that. It makes your programs a lot smaller, also makes them a lot more readable and easy to use. Code comments are another thing we really, really like. So having code where people can read and see what's going on is very good. Code that's unreadable and messy is not something that we like. Also, in your presentations, please bring your code if you have it. It's always a good thing to have, especially if you have a lot of like interesting functions or you're doing something really neat in there. We definitely want to see that. So, bring it if you can. It's not required to bring it, but it's highly advised to bring it if you can and if you have it. A lot of people also have master control programs, MCPs. A lot of people call them MCPs. It's where you basically have one giant function or one giant my block that basically runs each individual run for you, or each individual sortie for you, right? The advantage of that is that it makes it a lot easier for the operators to select what program they want to use and then run the robot, right? Generally speaking, when we talk about like using my blocks and encapsulation, we're not really talking about taking a whole robot run and putting it into a my block and saying, okay, we use my blocks. We're really looking more for like the functions, like, our following line function or turning a certain amount with the gyro function or something like that. That's the sort of thing that we're looking for with my block use. You obviously can put your whole program in a my block and use that in a master control program, but that's not necessarily the thing, the type of thing we're looking for when we're looking for my blocks and functions and stuff like that.
Jay, one thing you could talk about might be how to just big picture organize a team in terms of like goals and roles and whatnot that they might have for building and programming the robot.
Yeah, that's a great place. That's a great place to put some time. One of the things that's really awesome to see a team do is come up with a process of how they're going to run the season before the season starts, right? So talk about their process of, how are they going to select which robot, or how are they going to make the robot? If they want to change something in the robot, what is the process for that? If they want to add a new feature, what does that look like? How do you select a design in the first place? What if you want to change your design? Have like a defined workflow before anything starts. I know that can sound glorious, but it's actually a really positive thing to do. There's definitely a difference with teams that have a lot of process versus teams that don't. You can see when the teams have process that they're sort of not tripping over themselves, right? So if there's no change management, which is essentially what we're talking about, one person makes a change and then that will break, somebody else's thing or break several other things, then they have to fix that, and then it breaks something else, and then it breaks something else. And so you have teams repeating a lot of work over each other, which nobody intended or wanted to do, but they end up spending time going back and forth over their work again and again to make it work. So having that change management in the beginning and knowing that that's part of the robot building process is something that you can use to help prevent yourself from doing the same work over and over and over again. So I would start there with a formal design process. After that, have some kind of a work plan, do some strategizing. Think about, how far and how much time and how much energy you want to put into the season. The more time and energy you put in, the more learning you'll have, the better results you'll have, right? So make that commitment up front with what you want to put in, and then set what goals you have based on that. So, and if you exceed those goals, then that's great. And if you for some reason can't meet those goals, then that also was a good learning too. But having those goals is really important. That's also really, having goals also, and not just the robot, but in all the aspects, is really good. It's great for project, and it's great for core values. It's great for the kids to work together in a structured way that they are peers of in that process, right? It's not just a system of chaos. It's them choosing to work together in a structured way for the betterment of the whole team. Some other interesting concepts that you can have around that kind of idea. For example, one of the things we really like to see is having everybody have some level of participation in everything. It doesn't mean that everybody has to do everything equally all the time. What it means is that we want people to at least try to get out of their comfort zone and learn something new. So one of the things that can be really helpful, especially for teams that do a lot of programming and have a lot of programming expertise, is you can have those programmers on your team try to build their programs and try to focus their programming strategy essentially in a way where they're trying to make it more accessible for the rest of the team to work with the programming. So you can have maybe sort of a core programming team, and then you can have other people that are using the things that the core programming team makes in order for them to participate more fully, for example. That can have very positive results, because then that essentially allows the whole team to be able to build and program together, not just a couple of them or something like that. More questions? I'm looking for a direction to go. Could somebody give me a direction?
Do you want to talk about attachments, Jay?
Attachments. Well, we talked a little bit about attachments earlier, talking about fewer attachments versus more attachments. Generally speaking, fewer attachments I think tends to be a better solution, just because there's less operator involvement. But there are teams that have a lot of attachments, and there's some teams that do have a lot of attachments that do really, really well.
What are some good core attachments the teams should start with preseason practicing?
So preseason, if you want to think about attachments, don't think about attachments as one way to do one mission. Think about attachments as a tool that your robot has to accomplish a task, right? So for example, you might look at the table board maybe for last year or the current year, and you might say to yourself, what kind of attachment would be able to do these missions? Or what one attachment would do the most missions on the table? Stuff like that. And then start grouping missions together, not just by how close they are, but by what attachments they use. So before that's a great starting place, right? I can't take credit for this. This was something that one of my friends, Mark Thornblom, who works at NASA came up with. He came up with this concept called pick, place, push, pull. That everything on the table can be done with those 4 fundamental actions, and then those can then be associated with different attachment types. So that could also be like a cool way to look at it. You know, what types of different things can you group together? What are those fundamental actions that have to happen, right, for the robot to be successful? Talk about like attachment method a little bit. You know, lots of people have, you know, cubical, rectangular, solid robots, and then they have, you know, attachments that pop on very quickly on top, you know, or something like that. And that's a really good solution. That will get you very far in the competition. But there will come a point where you will start relying on that so much that you will find that it's holding you back more than it's letting you excel. So, and that can happen when you have too many attachments. For example, there's just too much stuff, right? Remember, this is only 2.5 minutes. It's not a lot of time, right? And so the more time that you're going back from base, sending your robot out and bringing it back and sending it out and bringing it back and switching your attachments, that's all time, right? What you really want is your robot to go out on the table and spend as much time as possible making points and coming back as little as possible. And if you start thinking about your attachments kind of like how much functionality can we pack into this at one time, rather than, you know, let's just have one mission per attachment, for example, right? You will find that, you know, you can accomplish a lot more in the same period of time, because your robot's spending time out on the table actually making points rather than just traveling back and forth, right? Now that's not free, right? There's some prerequisites that are going to come with that. Like, for example, good line following, you know, squaring up on walls, you know, for example, you know, maybe using an ultrasonic sensor to figure out how far away something is, right? You're going to need, you know, really good sensor use in order to stay out on the table and stay accurate. So getting that sensor use as a core mechanic down is going to be very, very helpful, right? So in terms of like, what are some things you know you're going to need this season? Probably line following, probably using the gyro, whether it's EV3 or Spike Prime, using the gyro and using the light sensor, maybe using the ultrasonic sensor if it's, you know, adequate for a certain task and that's a sensor you want to use. You know, making functions for those, making a function library for those, having conversions between like degrees rotation of the wheels to, you know, distance, you know, stuff like that. Having a really good, you know, library of stuff like that before the season starts is really valuable. Okay. Still talking about attachments, although we wandered a little bit. There are other approaches to attachments other than just putting attachments on the top or not having attachments at all. This is a technique I've seen done many times, but it's not as common. I like to call it a sort of like a core. It's a core design. And what I mean by that is the programmable brick and the motors are all connected in one core unit, and that whole core unit is put into different bases. And so what that does is basically turns the entire robot into a giant attachment. So you pull out your core out of one base, and then you put it in another base, and that other base, you know, hooks into all those motors, and then, you know, can be configured to do all sorts of things. Yes. Okay. So gyro on Spike Prime versus EV3. The EV3 gyro sensors are notoriously unreliable, and they have caused a lot of people a lot of problems on EV3. And when they were making Spike Prime, they're very aware of this, and they wanted to make that a better experience. So the EV3 has a separate gyro sensor the Spike Prime has that sensor built into it directly, right? It's in the programmable brick. And one of the big differences, other than just general accuracy and less drift, is it's now a 3-axis gyro. So it's not just rotation in one direction, it's rotation in all 3 axes. So for example, your robot could tell if it's turned up, for example, or if it's going up something, right? If there's rate basically of it moving in some other direction. So for example, that could be really useful if your robot has to go over something, right? Like if you have a ramp, your robot can now detect if it's going up a ramp because there's gyros in all axes. That's something the Spike Prime can do. With the EV3, you would have to have multiple rotation or multiple gyro sensors to do that. So the gyro in the Spike Prime itself is also a lot more accurate and generally has less drift. It's not perfect, but it's not nearly as cumbersome as the EV3's gyro. That being said, there are ways around and managing the gyro on the EV3. There's in the resource document that's linked, there's a really, really good article by someone named Jim Erbs, who's been involved for a very, very, very long time, since the very beginning, like me. And he has a wonderful write-up on like the actual, like what chips are actually in the sensors and stuff like that, like very deep technical details. So I would encourage you to read that, especially if you're using like the EV3 gyros, excuse me. And also one thing to note that the EV3 has 2 generations of gyros. There's a first gen and a second gen gyro. I think there's a way to tell between them. I forget it off the top of my head, but it does mention that sort of stuff in that PDF that's linked. The gyro, you can compensate for the gyro in a couple of ways, other than just doing like resets and stuff like that. For example, if your robot is still, if you know your robot's still, you can track the drift, right? So if you're still and it says, well, you're rotating, 40 degrees per second off to the left, well, you can compensate for that manually by having like an offset in your programming, for example, right? So if you can measure that and then directly compensate for that, that's a way of, mitigating some of the issues. Another really cool way I've seen people get around this is have multiple gyro sensors. And this is because the noise that you get in all the gyros pretty much for the most part evens out. And the most extreme version of this I've seen was actually a team that had 3 gyro sensors. And they called it the Democratic Gyro Voting System, the DGVS. And what they did is every time they took a reading, they took the two sensors that were closest together, and then they averaged them. And then the third sensor that was the furthest away, they just discarded that value. And that was extremely effective. The problem was that it used all 3, it used 3 rotations or 3, slots for the, for the sensors. So they, from a design perspective, they spend a lot on that. But it was incredibly accurate. And I saw it run on the table, and it was just beautiful on how accurate it was. But they worked really hard to make that happen, and it was very specific to address that particular issue.
Jay, you mentioned programming libraries. What are some things you think we should have the kids work on to build a programming library, like line following, squaring up? What ones would you recommend?
This is a great question. So turning, so with the gyro stuff, depending on the strategy that you want to go with, like for example, if you know that you don't want to use the gyro, then spend more time on the light sensor stuff. But if you are going to use the gyro, that's something I would start on early, especially if you're going to use the EV3, just because that can take a long time to sort of get all those bugs worked out. Proportional control is going to be, in terms of like continuous motion, is going to be a really cool and really beneficial thing, right? So for anybody not familiar with proportional control, It's basically the more deviated you are off of a target, the more correction factor you need to have, right? So having like a really good proportional, gyro turn function, and also a proportional gyro straight function, are going to be like core things I think are really, really useful. And then for the line sensor stuff, I kind of think of the line sensor stuff sort of in 3 levels. There's line touching, line squaring, and line following, right? So line touching is just, we found a line somewhere, right? And then line squaring is where you have multiple sensors, and you could technically have one, but most people do this with multiple, where you use each sensor to find a side of the line, so that way you can align to a line. And then line following, which is just where you continuously, follow a line. So doing this with proportional control is going to get you most of the way there. And then also properly tuning your constants. So for example, in proportional control, there is a gain constant, which basically controls, for whatever that level of deviation is. It's essentially a scalar value that's used to sort of magnify or decrease the the level of action that the robot takes to correct for a given level of correction that it's off of, right? So properly tuning those values, very important. You'll get the best results with tuned values, right? And that's a point of experimentation from a judging perspective, more, having charts, data, and doing experiments like that are numerically driven for tuning stuff. Very, very good. I know we'll get back to libraries in a minute, but I just wanted to, mention all of that. Okay. Yeah, let's see other ones that are here. Other things that are really good. Yeah, so libraries for converting distance. So being able to make, say things like, I please go forward, 5 inches or 20 centimeters or something like that, converting those degrees of rotations of the wheels into, linear motion on the board, that's always very, very effective. This is more advanced, but if you can do this, it can be very, very useful. Being able to smoothly accelerate and smoothly decelerate is also very, very useful. So without that, just by, if you just use sort of the default, hey, go at 50% power, turn on, go, what happens is that the robot will jerk. And when the robot jerks, it's going to lose traction, or it's going to make some deviation in its path, and then it's no longer going to be accurate. But if you smoothly accelerate, then you can keep your accuracy, right? Because you're staying in contact with the table the whole time, right? And you're not also inducing those that mechanical shock, that's going to actually change your heading or something like that. So smooth power on and, smooth power off, sometimes it's motor power ramping. And this is a really, really good concept also because it translates into industry, motor control in industry, in robotics, in automation is everything, right? Control theory is huge, right? And I know we're not doing triple integrals here. We're, making little trapezoid shape stuff, start up slowly, get to a certain point and go down slowly. But that concept is really, really powerful. And even just having like a basic implementation of that can be incredibly good on the table. So that's something to look forward to. Another good one, backlash compensation. Not a lot of teams do this, but the teams that do this can be very, very effective. So, every single one of the motors, no matter how good it is, will have some level of backlash in it, right? Like, there's some level of, let's see if I have one here. Nah, it's buried in there. If you take one of the motors and you try to move the input, right, it's going to wiggle. It's going to wiggle a little bit, and that's unavoidable. Every motor will do that. So what you can do is you can eliminate that backlash by turning your motors on at a very low power level so that your robot doesn't move, but it takes all that lash out of that drivetrain. And then you reset your encoders, and then you actually start with your motion. So then when you you don't have that issue of like when your robot starts, that one side is already wound up and the other side is not wound up, and then you get like a jerking motion, right? You start with both wheels fully engaged. Excuse me. Sorry, I was talking all day for work too, so my voice is going out a little. So you're running out, you took out the lash out of both sides, so that now when you start, you actually start moving the moment you intend to start moving. So backlash compensation, super, super good. Also for folks that use a lot of attachments, one really cool thing you can do, you can have a light sensor detect what attachment you have on. And based on what attachment you have on, automatically selects and runs a program for you. That's a really cool piece of automation that's, pretty doable for the most part to do. Okay. Those are probably like some of the core stuff, and then maybe some of the more advanced stuff that you could do. But a couple of other really cool things you could do if you felt like it, especially if you're on the EV3, you can build operator dashboards. So for example, you could have a dashboard that says, I'm running this mission. I know that there's a certain amount of time, in the match has elapsed. I know there's a certain amount of time remaining. And based on that, like you could display that on the screen. And the more advanced version of that is the robot can take some action based off of what time it is, right? So, if you're running a mission and you're running it at the end, for example, the robot might know that, hey, it doesn't have time to go over to this other part of the board to go grab this other thing, right? It says, no, I only have time for this one last mission. So then it goes and does that other shorter mission instead of the longer mission. It's something you can do. And that you could do on, EV3 or Spike Prime. But an operator dashboard can be really useful for the kids, especially because you don't need to look up and find the time. You just hit go. Also doing a good check, like at the beginning, you can write in your program, like make sure all the motors are connected, all the sensors are connected, stuff like that. That can also be really, really good, because if if you're accidentally have like something unplugged or something like that, that could potentially have a really bad impact on your run, especially if that's at the beginning, right? So you could have it run through like a little systems check at the beginning, basically to make sure that, everything's connected the way that it expects it to be connected, stuff like that. I know I'm jumping around a little bit, but just talking about like cool little programming things. So for a lot of the folks that use that do a lot of like top loading attachments, one thing you can do is you could have the motors just wiggle a little bit when you load attachments. So that way, when you go to put your attachment on top, it'll have more of a tendency to go on faster. So you won't have like things binding, tip on tip. They'll just kind of work themselves in. And so you can make your attachment changes faster. Another great thing you could do is show like, hey, we did some tests with our operators and they found that, before we added that feature, it was this fast. And after we added this feature, it's 20% faster on average, or something like that. That's a great analytical way to show like an improvement of something, or like say, hey, we had a problem with this. We had, we made a change and we had a positive outcome. Let's see, that's a good one. Some other good ones you could do. Time-based decisions we talked about. Okay, so you can have automatic override. That's another really cool one. Sometimes you see it's like uncommon, but teams that use this use it a lot. You can basically write your program in such a way where it's always tracking how fast the motor should be moving, and if the robot has not reached its target within an allotted amount of time, it'll automatically stop what it's doing and it will skip the block that it's on and then move on to something else. So it's very easy for robots to get stuck, while they're out on the board, and so that's a great way for the robot to realize it's stuck, and instead of just sitting there forever, it'll automatically go on to the next thing. The more advanced version of that is, for getting stuck at any specific point, being able to define like, if you get stuck here, this is the action I would like you to take. If you get stuck here, this is the action I'd like you to take. And I've seen that used really, really effectively. There was a team many years ago called RoboPro that did this very, very well. And what they did was, how it's really easy if your robot's going to go run on the wall, how it's very easy for it to get stuck on the wall. You have to get that angle just right, for it to smoothly go onto the wall. What they did was they knew that they were going to hit the wall and it was going to air out. And then they programmed it so that when it aired out at that specific point in the program, it went back and it turned a little bit and then it tried again. And it, sometimes had to do it once and sometimes it didn't have to do it at all. And sometimes it did it 3 times. Right. So depending on, the board, the table, whatever was happening that day, it was very tolerant of what angle it was coming in at the wall based on being able to automatically override. So that's a really good, like, in process use other than just getting stuck and then moving on. Let's see. Another thing you could do, post-run analysis. So if the robot's aware of like what it ran or didn't run or how well it was doing, collecting some data on, how fast its attachments were changed, if it's recording that, the time between when it came into base and when it left base, stuff like that. You can do a lot of analysis there to help your runners, and also just get a good sense of like how your runs tend to go. So there's a lot there. Does anyone have any like questions on any of that stuff specifically? Or questions about stuff like that whole programming tangent? Cool. So I'm good to talk as long as you want to talk. So I think we had a minimum an hour allocated to this, which that hour I think is quickly approaching. But I will sit here and talk as long as you want to listen, basically. Okay, I guess it's been an hour and a half technically, but programming questions, strategy questions, mechanical questions, programming questions, platform questions, strategy questions. I'm all ears. Okay. I guess we can wrap it up if thanks, Tim. If you're interested in holding like a second one of these, probably email Sarah Lubick about that. If you have specific questions, or if we sort of like start getting a lot of questions, we can always do another one of these and start addressing them. But we're just, at the end of the day, we're just trying to give you the tools that you need, for the kids to be successful. So just let us know, I guess. If there's other specific things. I suspect what's going to happen is like, sometime tomorrow while you're eating breakfast, you might come up with like 4 or 5 questions. So if you start having those questions pop up, email Sarah, and if we can reach like if we can get a couple of good questions in, we can hold another one. Cool. Thank you. Do you have any last words you'd like to say, Sarah Lubick?
I'm just curious if you're okay with me sending out a link to the document you shared along
Yeah.
with the recording.
Please
Okay,
do.
so I'll do that, and then you're okay with me sharing your email if they have
Yeah.
questions as well? Okay,
Mhm.
perfect. And then if there's a request for another session, maybe once teams get going with the season, might be a better time once maybe if teams have questions. We can schedule another one of these that is geared towards students, maybe student questions.
Yeah, I mean, if it's possible, it's always really cool to talk to the kids directly.
Yeah.
If they can make it onto the call, especially because they're they're the boots on the ground folks who are doing the work, are the kids. So, if you can get your team on here, I'd love to talk to them. I'm just one of many people also that are to talk to, right? We have Sarah Jones here who does a lot of core values, and there's also some really, really good project people out there as well, like Ken, to answer your questions, for project stuff too. So there's a lot of resources here and a lot of knowledge, and we really just want to reach out and help as many as possible.
Fantastic. Exactly. So as always, you guys feel free to send me questions. I'm happy to get you in touch with Jay, and we'll pull together all these items and send them out to all the coaches. So look for that as well. Thank you, everybody. Thank you, Jay. Thank you, Sarah, for giving us your time tonight. Thank you, everybody, for joining. Have a wonderful night.
Thanks,
you.
everyone. Thanks, Sarah.
Good night.
Good night.